All right, we are now on 3.3's extension. We call this linear programming. And this is pretty cool because this is where it gets into the real life stuff of solving systems of inequalities. The first thing we need to do is find the maximum and minimum values of the objective function subject to the given restraints. So what we're going to do is we're going to try to find the min and the max of this objective function equation right here, given these constraints. But in order to do that, the first thing we need to do is graph this system of linear inequalities. So to start out with, x is greater than or equal to 0. We start by graphing x equals 0, and this is going to be a solid line, and these are all going to be solid for these problems because they're always going to be equal to's here. Okay, so when does x get bigger? X gets bigger to the right of this line. So I'm going to keep track by drawing the arrows again. Okay, now we're going to go to y is greater than or equal to 0. Okay, and that's going to be the horizontal line through y equals 0. Okay, so that is actually the line on the x-axis. When does y get bigger? Y gets bigger above that line. Okay, so right now I can see that I'm shaded in this box right here on the graph. So now I'm going to go to graph this inequalities. First I subtract x from both sides. So we end up with y is less than or equal to negative x plus 5. Okay, so we're going to go to 5 on the y-axis, put a dot, and my slope is down 1 over 1, slope of negative 1. Okay, and then we'll draw that line in. See if I can hit those dots. Oh, I'm pretty awesome right there. All right, and then remember we plug in 0, 0 since it's not on the line. So I go back to this inequality. If I were to plug in 0, 0, I would have 0 is less than or equal to 5. That's true. So that means that this line is going toward 0, 0. So my shaded region is going to be this triangle right in here. Okay, so there's my shaded area. Now in order to find the min and max values for this objective function, what we need to do is find all of the points where these lines meet. Now that doesn't look absolutely perfect, but these lines meet here. That's where the shaded area meets. Okay, and these lines are going to meet actually right here. This is off just a tiny bit, but if you look closely you'll see that they're meeting here according to the slopes, and they're meeting here. Okay, so those are the corners of the shaded area. So I'm going to write those points down. Okay, first I have the point 0, 0. Okay, so the origin is one of those intersection points. This is the point 0, 5. And then out here is the point 5, 0. Okay, now in order to find out the min and the max, what I do is I go to this objective function and I plug each of these points in. My min and max are always going to be on the outermost points, and it's always going to be the points of intersection, okay, the corners of the shaded area. That's always going to give me the min and max. So let's plug in 0, 0. If I do that, I'd have 4 times 0 is 0, plus 3 times 0 is 0. That would give me 0. Okay, so the point 0, 0 would equal 0 for the objective function. Let's plug in 0, 5. 4 times 0 is 0. 3 times 5 is 15. 0 plus 15 is 15. Okay, so that would be the value at 0, 5. Okay, now let's plug in 5, 0. 4 times 5 is 20, plus 3 times 0 is 0. 20 plus 0 is 20. Okay, so 5, 0 would give me a value of 20. So now what I would say is we have a minimum, okay, so we'd write this out. There is a minimum of 0, okay, because that's the minimum value out of these three. There is a minimum of 0 at the point 0, 0. Okay, so there's the first part. And there is a maximum of 20. Maximum of 20 at the point 5, 0. Okay, so that's how we would answer the question. This problem is in your notes. However, I'm not going to go over the whole problem with you. I just wanted you to see what the final answer would look like. Oh, hi Batman. Let's turn this into a real-world problem. So we're at the craft fair. So think about the question. Okay, that is going to be your objective function. How many of each size piñata should be made to maximize profit? Okay, so let's think about profit. And probably even before that, we should probably write down what are our variables going to be. I'm going to start with M is going to be my minis. Okay, M is my mini piñatas. And then I'm going to let R be my regulars. Okay, my regs. All right. Now my objective function is going to be C equals, how do we want to maximize profit? Well, if it's $12 for a mini piñata, I would have to take $12 times my minis plus $24 for my regular size piñatas. Okay, that's the profit. So I want to maximize this. So basically what I'm going to do, this is my objective function. Now I'm going to find out how am I going to maximize that. So I'm going to have to come up with some inequalities. Let's start with the first part. Okay, it takes 2 hours to make a mini and 3 hours to make a regular size piñata. But it says the craft booth owner has no more than 30 hours available. So if I have 2 hours times my minis plus 3 hours times my regulars, it says we have no more than 30 hours available to make piñatas. So that would have to be less than or equal to 30. Okay, so that would be my first inequality. And that's just dealing with time. Now there's another thing I know. It says the craft booth owner wants to have at least 12 piñatas to sell. That means that my minis plus my regulars have to be greater than or equal to 12 because it's got to be at least. Okay? Now, there's one other thing that we know. The one other thing that we know is that you want to have at least one mini. So the minis have to be, well, you know, it doesn't have to be 1. It could even be 0. Okay, we want to find out how to maximize this. But we know that minis has to be at least 0. And regulars also has to be at least 0. So there are my 4 inequalities. Dealing with time, dealing with how many we're making, and this really is how many we're making as well. We know that there has to be greater than or equal to 0 minis, there has to be greater than or equal to regulars. Okay, so now let's decide here. I'm going to let this bottom axis be my M axis. That's for my mini piñatas. And up here, this is going to be for my regular piñatas. Okay, so it's like my Y axis is my regulars, X axis is my minis. Okay, I'm going to go ahead and graph these two first because we already know how those are going to work. Okay, so I'm going to start here, and again, these are all going to be solid lines. Okay, and I also know that minis are going to be at 0. And these are both going to be going bigger. Okay, minis has to be getting bigger, regulars has to be getting bigger. So these are going to both be going in a positive direction. So right now, this whole grid is really my shaded area. Okay, now let's, I'm going to solve both of these for R. I'm solving for R, remember, because I'm letting R be my y-axis. Okay, now I'm thinking we have plenty here. We can just go by ones. So I'm going to go ahead and go by ones looking at these inequalities because I'm going to be able to get up to 12. Okay, so let's start with this one. This says to go to 10. This line is going to be going down towards 0, 0. So right now I'm in the triangle. Okay, let's graph this guy. This says to first start up at 12. So this line here should be going away from 0, 0, which means the shaded region is going to be this kind of crazy looking triangle right here. Okay, so there's my shaded region. And again, I want to maximize profit, so I'm going to find the intersection points. Sometimes these are hard to read, so you got to be real careful. This is at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so we have 1 at the point 6, 6. And then we have, okay, that's 6, 6. We go 7, 8, 9, 10, 11, 12. 12, 0. And 12, 13, 14, 15, 0. All right, so now I've got my 3 intersection points, or my 3 points along the triangle here, the corners. Okay, now I'm going to go back to my objective function. This is the really important part right here. Okay, go back to the objective function, and we're going to plug these numbers in. All right, so I take 12 times 6. That is 72. 12 times 6 is 72. I'm going to write these out so I can remember. 72 plus, and then 24 times 6 is going to be 144. So when I add those up, I should get 216. Okay? Now let's plug in 12, 0. What is 12 times 12? 144. And then if I plug 0 in here, 24 times 0 is 0, so that's just going to be 144. All right? So when I plug in 15, 0, 12 times 15 is going to be 180. Okay, so I'm going to put 180 here. And then we'd have plus 24 times 0 is 0, so it's just going to be 180. So how would I maximize profit? Well, my maximum profit is right here. Okay, and this is the point that would get me there. So that means my answer, remember, 6 is along the x-axis, and that's your minis. So it would be 6 mini piñatas. And then this 6 is along the y-axis, which is regulars. So it would be 6 mini and 6 regular sized piñatas would maximize my profit. And that is going to conclude our linear programming.